So here the next problem is find the LU factorization, the pairs and the determinant of 4 by 4 matrix whose entries are Aij equals to smaller of I and j. So you have to first generate a matrix where the elements of Aij are smaller of I and j, where I represents your row and j represents your column. So you have to first generate the matrix and then you have to factorize it to LU factorization, find the pairs and the determinant of 4 cross 4 matrix. So first write the matrix. You can observe the matrix will be of this form. You can see the first row I is 1, so always I will be lesser than this is I and j are equal. Here it becomes 1 comma 2 and this becomes 1 comma 3. The smallest of that will be 1. And here it is what second row, first column 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4. So what will be the smallest? 2, 2, 2, and here the smallest is 1. So this is how you are going to write the matrix A. After matrix A, find out U. So by row reduced echelon form, I have done the row operations and I have reduced it to an echelon form. You can see that it has been 1, 1, 1, 1. So this is the row reduced echelon form, right? I can even reduce it to R. I have asked you, so I am stopping at U. This is your U, but you have to write the LU factorization of A. So what is the L is your lower diagonal matrix L. So that means what? The below the diagonal elements you have some values, that is non-zero elements, and above the diagonal it is 0. So it is a L value. So for the L value, I know that this diagonal has to be 1, 1, 1. So I've written 1, 1, 1, and above the diagonal it has to be 0. So that 0 has been written. I'll just name the other values as L21, L31, L32, L41, L42, L43. And if I multiply this L with U, I should be getting this A. So by row multiplication, I have the second row multiplied with the first column, I will get A21 and L21, and for L31 the third row multiplied with the first column I will get L31, and L32 the third row multiplied with the second column I will get L32 value. So same thing I have done here. For L21 the second row multiplied with the first column, what will we have? L21 equals to 1. L21 into 1 plus 1 into 0, all zeros, L21 equals to 1. And the third one is third row multiplied with the first column, L31 is equals to 1. Fourth row multiplied with the first column, I get L41 as 1, right? And what about L32? L32 is the third row multiplied with the second column. So you have L31 plus L32 equals to 0. So that automatically I know L31 is 1. So L32 will also be equals to 1. So like this you can find out the values and substitute that. See, all values you have got is 1, 1, 1. So it becomes that is transpose of U, I can see, right? Or the arrangements of U changes. So the fourth row comes at the last, fourth row and first row are exchanged, and even the third row and second row are exchanged, and they are written the mirror image. So that is your L and U factorization. And if I ask you U and upper diagonal, that is if this is U, and if I have an upper diagonal, if I represent it with like some value P, the upper diagonal matrix will be how? Usually this is the itself the upper diagonal matrix, right? L into U. U is upper diagonal. When you are reducing from A to U, you will be getting it as upper diagonal matrix. That itself we call it as U, right? U is written. To find out the determinant, you can find the determinant directly also. So here the determinant of A will be this L will be, if it is a diagonal matrix, this becomes a diagonal matrix 1, 1, 1. The product will be equal to 1, 1. This is also diagonal matrix. So the product of the diagonal elements 1 into 1 into 1 into 1. So that gives you total 1 will be the value, determinant value. So moving on to the next problem. Find the determinant if ai is smaller of ni and nj, where n1 equals to 2, n2 equals to 6, and n3 equals to 8. So here you have the n1, n2 values. It is similar to the previous problem. Instead of the column values, here the values of n itself are given. So you have n1 as 2, n2 as 6, n3 as 8, and n4 as 10. And can you write a general rule? You have to find the determinant value and then write a general rule, so that n1 is less than n2, n3 less than n3, and less than n4. So here first I'll try to write the matrix first. So while writing the matrix, it is a 4 cross 4, and have what the entries should be, whichever. This becomes 1 comma 1, that is n9, and nj is also 1. So whichever lesser value, that is n1, they are equal to. So all this here a1 2, a1 n1, that is n1 and n2 values. So out of that it will always be n1 is smaller. So here always n1 will be smaller, the first row. So I'm writing 2, 2, 2. And here it is also 2 comma 1. So here also 1 is smaller value, and here 2 comma 2, they are equal, and here a2 3 to a2, and that is n2 will be smaller value 6. So here 2 to same value, n3 n2 4. So again n2 will be smaller value, that is n2, and n4 I have to check. So like this I have to complete the values. So I have to check n2 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 n3 n2 n1. So depending on that, whichever is smaller, that you have to substitute. Okay. So after developing a matrix A, reduce it to find out u. They have not asked you any u and all. Just reduce it to A. Finding the matrix using A itself will be complicated. I can reduce this using a cofactors and find out the matrix, or you can go for even reducing the matrix to A to U form. So I have done here A to U form by row reduction method. So now it is in the diagonal matrix. You can see the below the diagonal elements all are 0. So it is a new upper diagonal matrix. So what will be the determinant? 2 into 4, 4 into 2, and into 2. That is 2 into 4, 8, 8 into 2, 16, 16 into 2, 32 will be the value of the determinant. So that will be a easiest method. And if you want to do the factorization, if LU factorization is asked, you can do that. If it is not asked, you can leave it. So just have shown here the LU matrix, same procedure. So you have on the upper the L matrix here, the diagonal is 1, 1, and the upper values are above the diagonal, it is 0, and below the diagonal, these are the elements. Just multiply, try to find out this. To find out this, second row has to be multiplied with the first column. To find out this, third row with the first column, third row with the second column. So you get these equations and write down the values. So we have got these values. So what is the determinant of L? It will be 1, 1, 1, 1 also. And the determinant of this will be, we have got it at how much? 32. So this is how we are finding out. So generalized expression, observing the pairs of u, they are equal to the difference between n of I plus 1 and I for I 1, 2, 3. So I can write it as n, n2 minus n1, n3 minus n2. So you can observe here what is your paired element. N1 was 2, and what were the elements? 2, 6, 8, 10, right? 2, 6, 8, 10. So after you have got u, what will be the u value? This is n as it is, and here it was n3, it was 2, 6, 8, and 10, right? So the first element n, the second part is 6 minus 2, that is n2 minus n1, and third is n3 minus n2, and fourth is n4 minus n3. So that has been generalized. Okay, 5 elements in terms of n1, n2, n3, n4. Okay, that is generalized expression. Okay, so let us move on to the next problem. So let us move on to some more problems on permutations and cofactors for finding out the determinants. So here we have a problem that question is asked. Suppose An is the n by n tridiagonal matrix. So tridiagonal, three diagonals, right? With ones on the three diagonals. You can see here 1, so you have only one value, and A2 two diagonals, this diagonal 1 1, and this is the third three diagonal matrix. So this is one diagonal, this is second diagonal, and this is the third diagonal. So all diagonal elements are 1 1 1 1. So this is the, if it is not given also, you have to write the form A1 A2 A3. So already they have given you, and you can observe the ones on the three diagonals. What is asked? Let Dn be the determinant of An. We want to find it. We want to find out. Expand. First question is expand in cofactors along the first row to show that Dn equals to Dn minus 1 minus Dn minus 2. We could have done it for other rows or other columns. So they have asked for the first row. We have to do it for first row. And then second question is starting from D1 equals to 1, D2 equals to 0. Find, that is find D3, D4, D8 by noticing how these numbers cycle around and find out D1000. Okay, so they have given you D1 because finding out D1 is mean 1 minus 1 0 or 1 minus 2 minus 1. So determinant D1 is the determinant of A was 1, so determinant will be 1, and D2 is 0. We can observe here determinant A2 is what? 1 into 1 minus 1, that becomes 0. So the determinant of this is 1. The determinant of this is 1 and this is 0. So the determinant of this you have to find out, and then try fourth one. So generalize it, find the equation, and then substitute in that and find the other values of the determinants. So here I can write, so for n cross 1, when I am generalizing it, I have to write it for 1 cross 1. You can see the tri-diagonal. This is one diagonal. So this is your one diagonal, and the second diagonal, and the third diagonal, right? So likewise you have to write. So when I'm writing the cofactors for this, so for the first one, if I am to find out the determinants, I'll go by cofactor. So taking the cofactor, that is for this one, if I'm separating this one and this one too, this will be plus 1 and this will be minus 1. So plus 1 minus 1, and leaving this for first element, leaving this row and this row and this column, what I'll be having 1 1, and here I'll be having 1 1 1, right? So this 2 ones and 2 ones 1, 3 ones will be 1 changing. Here also last row always will be 1 1, as I showed in the previous problem. So it will be diagonal, any diagonal when the n cross n, 3 cross 3, 4 cross 4, 5 cross 4, always the last row will always also have a 1 1. Okay, this is because of the primary diagonal, and this is one element below that. So automatically 1 1 will be ending. So here minus 1 second term is cofactor minus 1 raised to 1 plus 2, it becomes minus 1. So the size, when I am leaving one row and one column, the size of the matrix reduces to n minus 1 and n minus 1, n minus 1. So what will be the values of this? Yeah, you can observe the matrix. It is right, minus of 1 1 1 1 and 1 1. Here it is 1 1, and this is equals to your normal matrix itself. So I can write that in terms of as a normal matrix, that is a n minus 1 n minus 1, and this I can have the addition. If I'm doing the addition 1 minus 0 and 1 minus 1, that becomes what? Actually it becomes 0. So instead of that, what I'll do, I'll write the first matrix as it is, n minus 1 and n minus 1. So if I'm trying to expand the first this one, so if I'm trying to expand this 1, what I'll be getting? So minus 1, and if I'm trying to expand that, So leaving that column and that row, what I'll be getting 1, 1 and last 1, 1. So this if I'm writing, so the other values, leaving this row and this column. So I'm writing this, I'll be getting, so the size of that matrix reduces to n minus 2, n minus 2, right? And you can see the first now it reduces to what? N minus 2 and n minus 2. So I can say it as this as d of n minus 1 and this as d of n minus 2, right? So the other cofactors, that becomes your 0. Why I have not taken the other cofactor? You can observe here the first below that also I'll have, if I'm expanding this one, the other one also I could have taken. So that gives you the um, uh, first determinant minus the second determinant. So that this determinant and this determinant are of the same type. This is 0. This is minus. It can be operated for plus or minus. It becomes same. So I can have it as the same a of n minus 1 minus n minus 1 size. So it is something like a plus, I showed you a, b, same thing. In that form it will be. And just leaving that value. Again, finding the cofactor, I can write dn equals to dn minus 1 minus d of n minus 2. So using this, you can find out d3, d4, d5, d6, d7, up to d8 they have asked. So I am finding out all that. d3, 3 minus 1, 3 minus 2. So I'm having it as minus 1. Here 1, 0, minus 1, minus 1. Again I'm getting it as 0. And here you see, okay, again 1 and 1, 0. So 1, 0. Here it is repeating it. D1 and 0, 1, 0. Right? So the repetition starts at D7. So D7 is equal to D1, D8 is equal to D2. Similarly, D3 will be equal to minus 1. So it repeats the cycle length. You can say it is a repetition cycle of D0, that is D1 to D6, right? So D1 to D6, D7 again become D1. So keeping that into mind, I can find out the D1000 as the repetition cycle is 6. So for 1000, how many 6 I'll have? I'll have 6 of 166, 6 and the remaining 4. So if I divide this 1000 by 6, so I'll be getting it as 166 and the remainder will be 4. So 6 into 166 plus 4. So you know 6 repetitions, the cyclic, so it is equals to your normal value. So it is 6 raised to 4, I can check, right? This is the repetition cycle and 6 raised to 4 gives me the value. What is 6 raised to 4? It is nothing but d raised to 4. So that is minus 1. This is equal to the cycle 1000 repeats at d4 and d4 is minus 1. Moving on to the next problem, you have in the problem asked is in a 5 by 5 matrix, does a plus sign or minus sign goes with A15, A24, A33, A42 and A51 down the reverse diagonal. So you have the diagonal first, that is A, first row, fifth element, okay, and second row, fourth element automatically. It is in this fashion. First matrix 5 cross 5, right? So next element is here, third element, fourth element, fifth element. So it is a reverse diagonal. In the other words, P is 5, 4, 3, 2, 1. That is first row 5, 4, 3, 2, and 1. Even or odd. The checkboard pattern of the plus or minus sign for cofactor does not give determinant P. So here, how do you? I'll not have like plus minus for the determinant P. How I'll be finding? I'll be finding it by the row exchanges. So it is a permutation. All the factors I have to rearrange these terms. If I rearrange the terms and find out, I can find out the determinant values. So it will be what will be the determinant, that is P. Here, what are the exchanges I have to do? 1 and 5 if I exchange. So this is one exchange, 1 and 5. 2 and 4 if I exchange. So what I'll have 1, 5 here and 2 here, 4 here. So it will be in the order 1, 2, 3, 4, 5. So how many exchanges I have done? Minus 1 raised to 2 exchanges. So that is equal to plus 1. So the sign of the determinant cofactor will be equal to plus sign. Okay. So then moving on to the next problem, evaluate this determinant by cofactors of row 1. First subtract column 1 from the other column before finding the determinant. So first you have to subtract the column 1 from the other columns and then you have to find the determinant. So do that here. The matrix is given. After subtracting the first column from the other columns, what I'll have? I'll be having it as 4. The first column is 4. Subtracting column 1 from the other columns. So this first column and subtracting with the other columns, that is 4 minus 4 and 2 minus 1, 0 minus 2, 1 minus 1, that becomes 0. The third column, again column 1 has to be subtracted from this 4 minus 4, 0, 0 minus 1. So I am getting this 1 minus 2, this is your first column, right? And 0 minus 1. And the fourth column, 4 minus 4, 0, 1 minus 1, 0, 2 minus 2, 0, 2 minus 1, 1. So this is what I am getting. Right? So after that you have to find out the determinant. So now this was asked. So the same thing I have written. I subtracted 1 from all the columns. And now find out the determinant. So you have only 4 in the first row and find the determinant of that. So you can factorize it as 4 you are having, and then 1 minus 1 will be the cofactor, and reduce again the matrix here. So I have for this one leaving that row and that column minus 1, 0, minus 1, 1. For this minus 1, minus of minus 1, and the minus 2, 0, 0, 1. So expand that, what I will be getting, write the matrix. So after writing the matrix, you are getting it as minus 12. Just expand, you know how to find out the determinant. Find out that it will be equals to minus 12. So next is compute the determinants of A2, A3 and A4. Can you predict AN? So what is see the pattern of the matrix? You can see the diagonal element is 0, diagonal element is 0, and this diagonal element is 0, and all other elements are equal to 1. So use row operation to produce zeros, or use cofactors of row 1. So you have to find out the determinant of AN. The prediction AN is writing the matrix is you can write down, but in prediction, what you have to predict? You have to predict the determinant of the AN. So first we'll move on to A2, it is minus 1, and A3 if I am finding out using the cofactor, I am getting it as 2, finding using the cofactor, and A4 if I am doing it. So before going to A4, what has been done is that you are trying to get it into, this was a simple case. So for A3, for A4 what we are trying to get is that I am trying to reduce the matrix, that is, instead of try to reduce by R1, R1 minus R2 if I am doing, I am getting it as minus 1, 1 and 0, 0. These two terms become 0, 0, and finding out the cofactors for minus 1 and 1 I can do. And even I can trying to reduce this R4 to 0, 0 and 1 minus 1. Okay, so some of the row operations you can do to find out the matrix, or you can go with, if you don't want, if that doesn't strike your mind, you can go with the finding out cofactor for 1, 1 and 1 and find out the determinant. That also is going to be, you can do it. So here I have reduced, and now I will be finding it for minus 1 and for this one. So for minus 1, leaving that row and that column, so leaving this row and this column, I have 0, 1, 1, 1, 0, 1, 0, 1, minus 1. For this minus 1, I'll be having it for this minus 1, leaving this row and column. I'll get it as 1, 1, 1, 1, 0, 1, and 0, 1, 1, minus 1. Just if you want, you can find the determinant of 3 cross 3, or reduce it to 2 cross 2 and try to find out the determinant. So here I have 2 terms. For this matrix, I'll have 3 terms, and you can observe that plus, minus, plus, and here minus 1 plus 1, because first term is 0, and find the determinant value. It is equal to minus 3, right? So I got it as minus 3, and here what we have got for A3, we have got it as 2, minus 1, 2, and here we have got that as minus 3. Okay, so can you predict it for the other values? For A4, what we are getting? 4 we are getting it as and even the row exchanges, if you have to put, so how many row here, not row exchanges, we have done the row operation. So you are getting it as minus 3, and here you are getting for A3 you are getting it as 2, for A2 you are getting it as 1. So I can predict for AN, can I predict? Because for see, 1 lesser than this value I am getting, right? If it is AN, what I will be getting? A of n minus 1. Right? And if it is positive, if n is positive, then I am getting minus value, and if n is negative, I am getting it as positive value. So what I can write? I can write it as minus 1 raised to n plus 1, or n minus 1 also I can write, right? I'll write it as n plus 1. So when it is a raised to n is 2, 2 plus 1, 3, so that becomes minus 1, and the a value, the into that is sorry, not what I have to write. I have to write it as a n value will be equals to minus 1 raised to n plus 1. So minus sign goes okay with this. A2 minus 1 raised to 2 plus 1, that is minus 1 I will be getting. A3 minus 1 raised to 3 plus 1, 4, that I will be getting positive. And what I am getting? N minus 1 value. This is the generalized expression. So I can find out for a raised to n, I can find the determinant, minus 1 raised to n plus 1. Like if I want to find out for a6, a6 what I will be having? A6 equals to minus 1 raised to 6 plus 1, 7, and 6 minus 1. That is, this becomes minus 1 and this becomes 5. So minus 5 will be the answer for that. Okay, thank you. So one more thing you remember here, if you want to find out using the matrix values whether the terms, rows are independent, rows are for the columns also. So it depends on the values of the determinant. If the values of the determinant, you can find the determinant by any method, by reducing the matrix and then finding out the determinant, or by reducing its echelon form and finding the determinant. Any method you opt for finding out the determinant. And we call the determinants, the rows are to be linearly independent if and only if the determinant is not 0. If it is not equals to 0, then they are linearly independent. If they are dependent, one of the row becomes 0, either of the rows, one of the row becomes 0, that indicates that they are linearly dependent. Okay, so solve for the matrix and then find out whether they are independent or not dependent. And even for the columns, the same rules apply. If the determinant is not zero, then the columns are linearly independent. They are non-zero. When you will get determinant equals to zero, when any one of the rows is equals to zero, and that shows that they are dependent. So here the both the problems here they are asking you find the linearity by making use of by finding out the determinants of the matrix. So find out the determinant of the matrix and then decide whether they are linearly dependent or independent. So here in the example here you can see they are become zero, determinant becomes zero. So automatically the rows are linearly dependent. You can observe that here this matrix given 4, 4, 4. Here is 5, 6, 7. 5 minus 1 gives you 4. 6 minus 2 gives you 4. And 7 minus 3 gives you 4. So the second row is dependent on first and the third row. So it is a linearly dependent. Rows are not linearly independent. They are dependent. So the determinant value has become 0. Okay. So this is how we are going to solve the problems on factors and cofactors by using permutations and cofactors. So hope I think you have understood the topic properly. If you have any doubts, you can contact me. Thank you.